So, when can you use the Pythagorean theorem?
Calculate the area of a circle.
Not area. Gavin?
Find the hypotenuse of a what's called right triangle.
Right triangle. Excellent. Okay, so not any triangle, but it has to be a right angle triangle. How do we know if it's a right angle triangle? Like, is this a right angle triangle? Sean?
Well, as long as there's a right angle.
Right, like I have to see that little square right there. Okay, so that tells me that angle right there is 90 degrees. My line is a little crooked, but it's okay. So Gavin said something very important. This right here, this side, which is across from that 90-degree symbol, this is the hypotenuse. Hypotenuse. That's how you spell hypotenuse, not hypothesis. Okay? A lot of people like to spell it differently. What letter do we use to represent the hypotenuse?
C.
C. Okay, then what are the other two sides? Yep. A and B. Does it matter which side is A and which side is B? No, because they are the legs of your right angle triangle. So A and B are interchangeable. You can use either or. So what is the formula to find the hypotenuse? Yep.
Plus b squared equals c squared.
Right. And so the hypotenuse, aka the diagonal, aka the slanted height. Right? Remember this word slanted height? We will get to it later in the chapter. Okay, and you want to do the a squared plus b squared equals c squared. Okay, so what if I want to find a side length? Side length or the height in word problems? What formula do I use? Yeah?
C squared minus whatever equals the other thing.
Okay, good. Right, so remember a and b are interchangeable. So let's say I'm solving for a squared, then it's c squared minus b squared. Right, so whenever you're looking for the side, you're doing the subtraction. Whenever you're finding the hypotenuse, you're doing the adding. Okay. So for this one right here, am I looking? Can I first off? What's my A? What's my B? What's my C? In this example right here. Yeah, Jeremy.
19C.
Yeah.
17 by B, right?
Okay. Yep.
And then that's A.
Good. Okay. I forgot the unit as well, so let's say it's meters. Okay. But what was the most important thing in this diagram that I'm missing? Right angle symbol. So I can only use Pythagorean theorem if it's a right angle triangle. So even though, yeah, I was tricking you guys, I was asking you what is A, B, and C. Technically, you couldn't tell me A, B, and C unless I told you that this is a right angle triangle. All right, so since I'm looking for A, the side length, I'm going to use the subtraction one. So A squared equals C squared minus B squared. So 19, so A squared equals 19 squared minus 17 squared. This is a common mistake people do. They do 17 squared minus 19 squared. Can you have a negative length? No. Okay, so it's always the bigger number square subtract the smaller number square. Okay, I'm going to take off formatting if you do 17 minus 19. Hi, Carson. Hi. All right. Carson is this one, the next one over. Yep. Okay, so remember 19 squared is 19 times 19, and 17 squared is 17 times 17. After you subtract it, that means a squared is 72. So what's a? Yep.
8.5.
How did you get that?
I just found the square root of 72.
Square root. That's right. I don't want a squared. I want a. So I'm gonna square root 72. That's square root is the opposite of square. So when I do that, I get a equals what was it?
6.8.
Okay, so square root 72. You get 8.5. I'll round it to 1 decimal place. What's my unit? Meters, because it's a length. Good. All right. Right here, in terms of formatting, I would take half a mark off. Where did I lose that half a mark? Who can catch my mistake? I wrote down every single step. It looks very nice. It's legible. But where is my mistake? Gavin?
Meter square.
Not meter square. Meter is correct because it's a length. Is that what?
You put it on the diagram?
No, I'm not that picky. So you don't have to write it here. Yeah?
Should we use a decimal?
No, 1 decimal place is good. Take a look at this line right here. What's wrong here? Yeah.
It's not a squared equals that a equals 72 squared.
Right. You said here a squared is 72. And why we got that square root is because we were undoing that square. So it shouldn't be a squared equals square root 72. It's just a equal. All right. And I'm telling you this because it's so common. And people do that. It's just a. Once you do that square root, the a is dropped. The square is dropped. Okay. And another common mistake people do is they forget to square root it, and then they say that a is 72 meters. Does it look right if we hit 72? Yeah, it seems a little too long. Now let's say it's not so extreme, and I get that a is 20. How do I still know that's wrong? Yeah.
A is shorter than B, and B is 17, so it can't be 1.
Not B, but you should compare it to.
It's shorter than the hypotenuse, and shorter than C.
Right. C, your hypotenuse has to be the longest side out of the 3. So my answer has to be less than 19. Right? So that's one really important fact for you to always check. A lot of people make that silly mistake. All right, so this one, let's say all my length are centimeters, in centimeters. This is my C, because it's right across from my 90 degree. This is my A, this is my B. So since I'm looking for the hypotenuse, I'm using the adding one. C squared equals A squared plus B squared. So C squared equals 5 squared plus 13 squared. So C equal the square root of 194. And when I square root it, I get 13.9. What's my unit? Centimeter, because it's a length. Good job. Okay. So this was a nice little refresher of Pythagorean theorem, which you guys learned in grade 8. There are some practice questions on this on page 10 to help you guys refresh your memory and have the practice. So, but as I said, you learned this in grade 8. So what's new in grade 9? To apply it into our problems. So we're going to talk about perimeter and area of composite figures. What's the definition of composite figure? What are they? What's composite figures? Anyone know composite figures? What's composite figure? Frank, do you know what are composite figures? Hiroki, composite figures? All right, so Frank, Hiroki, let's pay attention. Anyone else? What does the word composite mean? Yeah?
Like there's more than one shape in the thing.
Exactly. That's exactly what it is. So 2 or more shapes put together. Right? That's what a composite figure is. So right here, if I want to find the shaded part, what shapes do I see? Yeah. And yeah, that's it. So if I want to find the area of the shaded part, I just use the area of the parallelogram. Take away the area of the circle. Right? Who remembers the formula for parallelogram? John? Yeah, it is. This is actually just space times height, because if you cut this part of the triangle and put it over here, you'll get a rectangle. What about area of a circle? What's the formula for area of a circle? Yeah. It is pi r squared. Good. Ooh. So looking at this diagram right here for the parallelogram, what's the length of the base? 11. Good. And Radine, the height? Yeah. All right. What number is pi?
3.14.
Wait, 3.14. Don't make it your own number. It won't work. So, and what's the radius of the circle? 2. Carson, where did you get to 2 from? Half the diameter. So this is a diameter of the circle. Radius is half of it. So it's actually 2. Right? So 66 minus 3.14 times 2 times 2, I get 12.56. So when you subtract it, you get 53.4. We'll round it to 1 decimal place. Okay, full marks? Why not? Still half a mark. Still half a mark off. Centimeter square. Why is it square? Area. Area is square. Length are just that. Okay. Okay. So does that mean if you don't know these formulas, you're gonna get 0 out of 3 for this question on the test? Okay, Joshua, why not? Yeah. Why am I so nice to you guys? Remember on Friday when you guys got this package, I said this on page 3 and 4, you will be given this formula sheet. Okay, so if you take a look at this exact formula sheet, you'll see perimeter formulas for all the shape and area formulas for all the shapes. All right, so this exact page right here. All right, but you all obviously you have to look at it. You have to remember that I gave you the formulas and not copy it down wrong. All right, but yes, I will give you guys the formulas. So there you go. Okay, so what about this? What shapes do I see here? Stefan? Well, it's not a regular pentagon because the lengths are different. Right? I see the semicircle. What else? Yeah.
Square and a rectangle and a triangle.
Why is it rectangle, not a square?
The sides are different.
Right. The size. This is 8. This is 5. Right. So on the test, the diagrams are not going to be drawn to scale because, in a way, is to trick you to make sure that you guys recognize the dimensions. Okay, so does that mean I'm gonna do area of a semicircle plus the area of a triangle plus the area of a rectangle? All right, Joshua, why not? Right. Yeah. Okay. I've seen it so many times on tests. People write me like 10 lines of work finding the area for me. And then they get 0 out of 4 because that was not the question. The question is asking you for perimeter. But so if you find me the area, you just wasted 5 minutes of your life. Okay? Make sure you read the question carefully. How do I find the perimeter of any shape?
Add up the sides.
All the sides, like.
Like for the rectangle, you can add up the sides, and that'll give you the.
Oh, that's the common mistake people do. Okay, but what's the general easiest definition for perimeter? You add up what? Add up
All this.
not just all the sides. We'll be more specific. How many sides are here? How many sides am I adding up in this diagram? Huh? Outside. Add up all the outside. Outside. So I'm only adding up these 5 sides right here. Stefan, what you said is another common mistake people do. They find the perimeter of the rectangle, they find the perimeter of the triangle, and then they find the perimeter of the semicircle. What's wrong with that is you added the inside, right? Okay, so make sure it's only the outside. Okay. What do we call this? I just want the perimeter of that semicircle. Instead of perimeter, because circles are so special, they have a special name. Yeah? Circumference. Who remembers the formula for circumference of a circle? If you don't remember it, it's on your formula sheet. Page 3. Yeah. 2 pi r. Okay, so 2 times 3.14. Again, what's my radius? Yeah, good job, Carson. 3.5, because half of my diameter. So when I multiply all this, 2 times 3.14 times 3.5, I get 22. Right? If I round it, it's 22. Right. Is it 22? Because it's half a circle. Divided by 2, because I only want a semicircle. Alright, so for the highlighted part, it's 11 centimeters. Right. So now I can add up the perimeter. Okay, so Frank, can you tell me what to add up?
Half of the circumference of the other side is
Which is? So 11 plus.
plus A plus 5.
That's it? Is that it? Yeah. Alright, as we said, only 5 sides. Right? I shouldn't see the other 7, I shouldn't see the 5. So when I add it all up, I get 39. What's my unit? Perimeter. Huh? Centimeters, because it's perimeter. Okay, so perimeter, centimeters. Area, centimeters square. If you have the wrong units, it is half a mark off each time. So make sure you don't miss these silly marks. It adds up. Okay. So that's the lesson. For homework, I want you guys to do page 10. All of page 10 is on Pythagorean theorem, and then page 11 to 14, just do parts A and C for each question. All right, because if I just assign page 10 to 14, that's a lot of questions. So all of page 10, and then page 11 to 14, for each question, just do parts A and C. So 1 AC, 2 AC, 3 AC, and so forth. Okay, so I'm cutting your homework in half for you. All right.